Hello and welcome. In this video we will introduce you to MVTec MERLIC's deep learning-based detect anomalies in the Global Context tool. If you do not know what exactly Global Context Anomaly Detection is, we recommend you to watch the video Global Context Anomaly Detection by MVTec before watching this tutorial. As with all deep learning-based technologies featured in the MVTec portfolio, the workflow can be divided into labeling, training, evaluation and inference. The last step, the inference, is performed within MERLIC. The offline steps labeling, training and evaluation must be performed with either Halcon or the deep learning tool. We strongly recommend the use of the deep learning tool, as shown in the video how to train and evaluate a global context anomaly detection model with the MVTec deep learning tool. In this tutorial we will use the same application as in the example MV app detect anomalies of bottles in the global context.mv app, in which we want to detect structural and logical anomalies on these juice bottles. Right now, our MV app only contains an image source manager that acquires our inference images. From the tool library under Processing, Deep Learning AI, we add the Detect Anomalies in the Global Context tool to our tool flow. The added tool automatically connects to our Acquire Image from File tool. Next, we want to import our trained Global Context Anomaly Detection model. Click on Model File, Browse, and select the model you want to import. As soon as MERLIC loads the model, the tool starts working. Let us go through the input parameters. The parameter use internal data of model defines which data of the model is used for the inference. By default, the parameter is set to all. The value all means all internal data of the model is used, threshold and regions. You can also choose to only use the thresholds, only use the regions, or use none of them. Using the model determined thresholds transfers the internal data to the parameters anomaly region threshold, anomaly score threshold, anomaly score tolerance, and minimum defect area. These cannot be edited while using the model determined thresholds and will be grayed out. Using the model determined regions will stop you from manually defining a region of interest to restrict the domain of the global context anomaly detection. We set use internal data of model to none. This makes the parameters anomaly region threshold, anomaly score threshold, anomaly score tolerance, and minimum defect area manually adjustable. It also allows us to define a ROI. Defining a ROI allows us to exclude areas from the decision making of our network. As we exclude the anomalous area from our inspection, the value of anomaly detected changes from 1 to 0. Note, restricting the domain of the global context anomaly detection does not influence processing times. Processing time is however influenced by the processing device. MERLIC's Detect Anomalies in the Global Context tool not only supports CPUs and GPUs as processing devices but also supports the optimization of your model with TensorRT for NVIDIA GPUs and OpenVINO for Intel CPUs. With the installation of the official toolkit, OpenVINO optimization can also be used for Intel GPUs and VPUs. We now switch to the front end of our MV app, which is identical to the front end of the example Detect Anomalies of bottles in the Global Context.mv app. You can clearly see which images contain anomalies. In the top right corner, anomalous data is indicated by a red light. Additionally, the heat map shows where exactly these anomalous regions are. The heat map can be turned on and off here. We can also alter the value of use internal data of model. Because we set it to none, we can adapt and delete our region of interest, while inside the front end. You can step through your data using this button here. This concludes this video. Together with the video how to train and evaluate a global context anomaly detection model with the MVTec deep learning tool, you should now be able to train, evaluate and import your own global context anomaly detection model into MERLIC. Thank you for watching.